all of them, just some of the popular ones.
Recording is on.
And so we're going to talk about API wars, and we're going to have three API protocols that we're going to explore today, and this is going to be a panel discussion, so feel free to ask questions. You can either use the raise your hand feature or type in the chat. I'll monitor it and make sure that the presenters are aware that you have a question, and we'll take the questions as they come. After you get an overview of REST, GraphQL, and gRPC, then we'll start the panel discussion. The panel discussion will be basic around the experiences type of thing and any questions you may have. So just do the raise your hand and or type in the chat. Without further ado, we'll start with the first one. That would be REST. Let's see here. I believe it's REST.
I'm happy to go first, regardless of the...
And so we got Daniel Laughland to talk about REST.
All right, thanks, Jason. Yeah, I will share my screen here. Hopefully that's coming through all right. If it doesn't automatically switch you, I think you can scroll through the grid view and click on things to make it your full screen. If the video quality isn't good enough, I'm going to drop a OneDrive link in the chat here so you can follow along locally if you can't see the presentation, but hopefully that's coming up for everybody. So like Jason said, my name's Dan Laughland. I'm the development manager for Novus Home Mortgage, which is headquartered in Waukesha. But I'm here today to talk to you about REST APIs and what those are and how they get used. This is kind of like the default option for a lot of people. It's so deeply baked in to HTTP and everything that we do with web interfaces that it's hard to avoid coming really close to REST. If you're not explicitly trying to do this, you may accidentally find yourself writing a REST API. So we'll go through kind of what the specific properties are that are different than just general HTTP messages back and forth. So REST, the acronym stands for Representational State Transfer. The first word kind of pulls double duty there, but the origin of this term and where it all came from is, back a million years ago in the year 2000, the web wasn't new, but we were still kind of getting our footing around how everything was going to work, especially on a global scale for a lot of these things. And one of the original authors of the HTTP protocol, his name's Roy Fielding, was working on his PhD. And his dissertation was to kind of take all of these ideas that they had floating around and all of the feedback they'd gotten on the first couple versions of HTTP and distill it down to a specific set of principles that they felt were going to really drive the web to be a global scale and the global phenomenon that it has become. So a lot of the outcomes of his dissertation work kind of turned into what we know as HTTP 1.1. I know 2.0 and maybe even 3 is the latest version, but this HTTP 1.1 really stuck around for a long time. I think 2000 or 2001 is when the RFC was published for that. So this is really just kind of the core philosophy behind a lot of this stuff. The main principles that they were thinking of when they were building the web is we want this to be really easy for people to start using. A low entry barrier. We want this to be extensible. It should be easy to add your own flavor to it. Distributed hypermedia. We want things to link to other things all over the world. And we want this to operate at internet scale. It should be able to grow and become a performance scalable system with all of these things. So with those goals in mind, they kind of came up with this as the REST architecture. And these are kind of loosely called the Fielding constraints from Roy Fielding's work. And I'm not going to go through all of these. You can read Wikipedia as well as I can, but the important parts are kind of over here on the right side. And these are, if you want to have these properties in your API, in your system, which are desirable things for the internet, then these are the constraints you need to put onto your system. The three API structures we're talking about today have most of these in common, so I'm not going to go into detail about all of them, but the uniform interface is something that kind of stands alone for REST, and this is called out as specifically, this is what makes a RESTful API RESTful, is if you're following this uniform interface and all these other things. So I'm going to dive into that a little bit deeper now. Again, this is a PhD dissertation, right? So this is a little bit of word soup. It's not really written for us mere mortals, but I'm going to try to translate what these requirements mean and in the context of HTTP messages and how we might use them every day, and in a couple spots how not to use them. So the first point that is in the list is resource identification in requests. What this basically means is that when you're using an HTTP system, your URLs refer to resources. And these are like your nouns, right? They aren't going to refer to actions. So you might see a URL that points to products to get the list of products. You might have a URL that points to a specific product, right? It might be identified by ID or a slug line or some other thing. But the point is it's referring to a specific thing, a specific product in the system. And not to get details or add to cart or create order. You won't see URLs like that in a RESTful API because URLs are supposed to refer to nouns. So that's what they mean by resource identification request, is that you're referring to resources here. The second point is that we manipulate these resources through representations. And that essentially means you can interact with this in many forms, right? So when we look at the representation of the cheese pizza, here it is in JSON form. This is one way that it might get sent back to us in a RESTful API. And this is our representation of the cheese pizza product, right? It could equally be sent back to us in XML form, right? It could look like this, and this is our representation of the cheese pizza. Similarly, we have, when we're manipulating objects, when we want to change things, we'll have representations of what the changes are that we want to make. And that's what we're interacting with, and primarily is through these representations. Now I'm showing you what would be considered like the request or the response body here, but there's a whole separate part of HTTP in the headers, right, and other things. So the third point in the uniform interface is that you need self-descriptive messages. And what that means is that the HTTP message, the request and the response, together should tell you everything that you need to know about what you want the system to do, and for it to tell you what happened, and in many cases, what you can do next. So here's an example of combining now a verb, an HTTP verb of get with the URL. And I tell it I accept JSON. You can send me the JSON type back. And the system responds back and says it was okay. I'm sending you JSON. Here's some info you can use to fill in your cache. And then here's the actual body of the message. In a different example, we might use a different verb like patch. This is one that's a little more esoteric. Not a lot of people use HTTP patch on a regular basis, right? But if I wanted to patch my shopping cart, to say add a pizza to it, or 5 pizzas in this case, right? The entire message here is telling the system everything I want it to do and how to do it. I'm telling it I want you to patch this particular resource. I'm telling you the parser that you're going to use on the data that I send you, and then here's the data that I'm sending you. And in response, the system tells me 204 no content. That it starts with a 2. That means it all went well, and it's saying I have nothing further to tell you. In some cases, maybe it would send back, now here's what your cart has in it. That's perfectly valid. This is just one example. And maybe you have to turn around then and say, give me the cart again, and then it'll tell you the contents, right? So we kind of have this back and forth with these self-contained messages that are the complete operation, right? So we start with the resource, and then we say what we're going to do with it, and any other additional metadata to tell the system what's going to go on. And even when something goes wrong, we have all of that accounted for in our messages. So if I were to try and post an order now, right, there, again, not a method called create order. I'm talking about an order specifically. I want to create a new one. That's what post means, right? That's the HTTP verb post. And maybe it says, nope, you can't do that. That's a bad request. And then it can give me some more information about that, either in the headers or in this case, in the message body. Either way, I get everything I need to know about how to process this in that message. So the last point is full of opinions, I guess, and that's using hypermedia as the engine of application state. You might see this acronym as HATE OAS. But what this means is you're using links to tell people what you can do next. And I'm going to start here with an HTML example because it's actually kind of rare to see this in system APIs. But if you think about a website, right, when I go to somebody's homepage, my browser has no pre-existing knowledge of what it can do there, right? I load up, the meetup.com. My browser has no idea what's going to happen next. It figures that out by looking at the hypermedia or the hyperlinks in that HTML page. So HTML is one form of a RESTful API, actually, and probably the only one where you see this on a regular basis, right? This hypermedia. But the point is, you don't have to know ahead of time what can happen. You find out the references to the next things based on the content that was sent to you. So in the context of a RESTful API, maybe we're looking at this cheese pizza here, right? And I know that the system has product reviews for these things, but how do I get to that? Right? Do I add /reviews to the end of this? Is it /reviews/ this pizza ID? You don't really know unless the documentation tells you, or if the response for this product tells you, right? It's perfectly conceivable. You could have a piece of the response that says, hey, here's the links that are associated with the pizza product. And if you want the reviews link, you're going to go to this URL. And it turns out it's something completely different, right? I'm not saying this is good API design. Don't do this. Use consistent IDs. But even if you didn't know that, even if it was a poor design or inconsistent, because you have this link structure, you can figure that out from the response data. That's one of the key pieces that makes the web so expandable and so interconnected, is this concept of hyperlinks. And incorporating that into APIs gives you a lot of power in a way. So we'll come back to that. But that's kind of the quick tour of the uniform interface of REST. So now you kind of know a little bit more about what these sort of academic phrases mean and what that looks like in real life. And the advantage of following all this is that RESTful APIs get really predictable for developers, right? If you know that an API is RESTful or striving to be RESTful, you can count on a lot of things going in a consistent way. The URLs are your nouns. You can predict what verbs you're going to use the HTTP verbs of get and post and put. The headers are all standardized. The status codes are all standardized. They're consistent from API to API to API. And that's baked into HTTP. Every browser, every debugging tool has these patterns built in. So that gives you a lot of predictability, a lot of control. In more of a pragmatic and very real sense, REST is also extremely unpredictable for developers, right? And here's like my top 10 gripes about RESTful APIs and what they don't do well. And I don't have time to go into all of these, but I'll just talk about a couple examples. So say we've got different pages of products that come back. If it's a very big catalog, maybe it's too many things to give me in one response. So do I say page equals 4? Do I need to give it a page size? Is it maybe a cursor-based system where I start with one and then have to pick it up later? There are HTTP headers that are designed to do some of this, but no one ever uses them, and to do these range responses, right? So there's a lot of different options. That's not part of the REST standard. This isn't really baked in to the standard in the way that the rest of the uniform interface is. So it's hard to know ahead of time how that's going to work. Similar, the structure of data. If I say get product, am I going to get a bare array, or am I going to get an object with a product's property and maybe some other stuff in there? It's difficult to know ahead of time what's going to happen. Searching and filtering is a similar thing. Can I search? Is this a feature of it? Can I give it a specific filter type? As much as we talk about browsers and clients not knowing anything, or browsers and servers not knowing anything about each other, in a lot of pragmatic applications, you do need to know a lot about the server ahead of time. There have been a lot of efforts to standardize a lot of these things. The ones on the left have been somewhat successful, or at least present currently in my experience. There's the idea of Swagger documentation or open API. OData is something that Microsoft has been a big champion of, and that lets you, control your API responses. Atom Pub, that old XML format, is still out there, still kind of going strong. Like, it does all of this stuff. It's even got, relational links and everything available. And there's a whole alphabet soup of standards that never really took off. Maybe you'll find them here and there. But the point is, there's a lot of ideas and a lot of extensions on top of the standard HTML stuff that you have available. And you can make these standards part of your API to try and make it more predictable for your end users. So talking briefly about how REST appears and is used in the .NET world. On the client side, if you're a consumer of REST, like, really the HTTP client out of the box is going to do everything for you, right? It's just HTTP at the end of the day. You can set your headers, you set your payload types, back and forth you go. The framework, ASP.NET, has the HTTP client factory in newer versions. If you have not checked that out, I highly encourage you to check that out. It makes it very slick and very easy to make a nice typed client for yourself. And then on the server side, if you're creating an API, you get a lot of what I called the predictable parts. You kind of get that out of the box with ASP.NET and with Core as well, whether that's Web API if you're on legacy framework, or just in Core if you're doing controllers. But for all those unpredictable parts, that doesn't come out of the box. The NuGet ecosystem is really rich. There's options for everything, but you are going to have to wire a lot of that stuff up yourself. So that's kind of the pros and cons of REST. I think that's my time. That's what I've got. I'm on Twitter and everywhere at Jabberwick if you have questions, or I will be on the panel for questions later.
All right. Thank you, Daniel. Up next is GraphQL, and we're going to have Martin Hollstein talk about that. Sorry.
All right. All right. Cool. Someone want to know if it's sharing correctly?
I think you may have to unshare if you were sharing. And then scroll to that person's name or to you, and then click on that to see that one. I can see GraphQL.
Cool. Awesome. All right. Yeah. So as stated, I am talking about GraphQL here. What is benefits, shortcomings, and examples if we have a bit of time in the 10 minutes. First, my name is Martin Hollstein, he, him. I've been developing for 8 years. 3 years I've been spending time doing architecture and infrastructure development. A lot of that actually involved architecture and infrastructure for GraphQL environments at a few engagements, as well as going out and speaking with other clients about some of the technical capabilities of GraphQL. If you want to stalk me on the internet, you can find me at holstein.dev. Cool. So first off, what is GraphQL? It's a type system that's well defined through a strongly defined specification, and it has the ability to be introspected through its strong typing and schema definitions. It is designed specifically to solve the problem of having multiple APIs for multiple different clients, and that's not just different applications, but that could be different applications on different platforms, such as mobile, web, VR, what have you. It is an alternative application protocol to something, not only what we have here for REST and gRPC, but also lower down. Most implementations are done in HTTP just because we're working over that as developers in the most common cases, but it could also be implemented strictly in raw TCP if you really wanted to. So the specification is more about the application protocol. Right. So the data, which is done through a GraphQL schema document. This would typically be implemented on your application server. And what we have on the right side is an example of what a very basic generically named schema would look like. You can, like most languages, define a type. So you can define the layout of an object. and you can define how that object is queried for in the query type, which is a reserved keyword, and then also how data can be manipulated through the mutation type, which is also a reserved keyword. The base GraphQL specification supports the structure of objects through several scalar types, such as int, which is a signed 32-bit integer type, float, which is double precision, string, which is UTF-8, Boolean, true or false, and ID, which is probably the more surprising ones to see. Really, it's just an opaque identifier meant more for machine consumption than human consumption. So typically, it's something you wouldn't see as an end user, more used for navigation around the schema. And as you can see, it supports the concept of non-null fields. That would be the exclamation mark you see in the example, and arrays, which is anything in brackets. Right, so that's just a quick view of what a schema looks like. When you have defined a schema, you can hit the server and ask for what you want through the use of query documents. Query document looks pretty similar to the schema, except you're not going to be explicitly defining the types. You're just going to be describing the data you want. Typical terminology is nodes and edges. So if you're familiar with graph theory, those are going to be pretty common terms. When querying for data, you need to query for at least one field. So that's any non-object type. And the result will come back in the manner as queried, which we'll be able to see in the next slide. One of the key benefits that you see from this is that it reduces the amount of data sent over the wire when you have a client application that only needs a specific amount of data. So instead of requesting for a specific object and getting every field on, say, a mobile device that's on, a 3G network for some reason, and basically swamping it, receiving a response, your application could instead request the 2 fields it needs and hopefully reduce that response size. So after asking for what you want, you'll also get predictable results. These are guaranteed through the schema documentation. For instance, if you remember the example schema, the integer within the integer array was marked as non-nullable. Therefore, you can be guaranteed that if there is a value, the value will be a valid value. You won't have 10, 5, null, etc. You'll just have integers. And you can see that arrays, you don't have to do anything specific to during the query. They will come back as arrays. However, this sometimes leads to confusion. So naming conventions are probably encouraged, such as using plurals when you have a field as an array. Other than that, pretty much everything's going to be predictable. And the most predictable part is you can look at the schema and see exactly what you're going to get. You don't have to query the API first in order to see the shape of the data as it comes back. You'll be able to ask the server, what does the data that you're going to send me look like through what's known as an introspection schema. And essentially that will just return the schema document. So after going through a quick rundown of what GraphQL is and kind of what it looks like, we can look at some of the pros. The biggest one is that it is a well-defined specification. So there are strict rules about what you define within a GraphQL document and what those markers are. And that's primarily focused on the schema document and the promises you're going to be making, such as things are going to be arrays, they're going to be returned in this shape, and they're going to be null, not null. Due to that, your APIs become well-defined. There's a lot less get work, and traversal of the data is self-discoverable in that you don't have to request data, see how it relates to other data within the system, and make more requests. You just make the single request due to the fact that GraphQL describes everything as a graph. So you traverse down into the objects and their relationships, as opposed to making multiple calls to create those relationships. The documentation is also built in and supported in GraphQL. The schema document gets you halfway there in that you are describing what your data looks like and the types it is and the promises you're going to be making for that data. Sorry about that. Promises you're going to be making for that data. The other half of it is going to be inline comment, which is just like code comments. The only difference is the majority of implementations of GraphQL will also expose those comments. So you can actually write technical documentation inside of your schema. And it's not only a benefit to your developers who are looking at the schema, but also anybody else consuming it who you may not have any interaction with. Great benefit is one API for many client platforms as the primary solution to the problem statement. This is because we live in a world where we have a myriad of different types of platforms that we can deploy our applications to. Again, mobile web applications are two of the most common we're going to see. And by providing a single API that allows you to trim and look for data in the way that is best for your application is one of the largest benefits of using GraphQL. Through that query and trimming of the responses, you're going to reduce your network usage, which could improve performance and cut some costs if you're in the cloud. And then the other thing is, because GraphQL is so new, a lot of the web server applications are being implemented for GraphQL, or the frameworks that are being implemented tend to have modern practices applied to them in implementations, and there's a lot less legacy code lying around and code sitting around for support for, say, outdated specifications. So you're just going to get newer practices within the frameworks that implement GraphQL. Some of the cons of using GraphQL is that because your data is being laid out differently and it's laid out as a graph, there is a strong potential for recursive resolution of data, which, if not paid attention to, can cause very easy DDoS attacks. No images or raw documents are supported. There are ways to do it in GraphQL by defining a string that's essentially just the raw encoded data of an image or document. However, that's really not recommended, and it makes responses really big. It's better to actually expose the metadata of an image or document and then provide a link for that image or document. It's still a young solution, so not every use case or edge case has been expressed or seen and solved yet. So there may be some things you'll have to take care of yourself as a developer when it comes to using GraphQL. Again, just even the previous example, how am I going to do images? Embedded or as a separate service that is probably done in a more RESTful manner, or just straight up just HTTP. Your engineering practices are going to change. Dates aren't a supported, well, they're not a native scalar type to GraphQL. So now you have to decide how you're going to handle it. Is it going to be a string? Is it going to be an integer? Who's parsing it? How do you format? Is the server going to format it for you, or are you going to do it on the client side? Enums are a data type that you can describe in GraphQL, and the biggest discussions I've seen is, are you going to make it readable for machines or humans, as far as the values and the representation of those enums? Unions are introduced as well. They, I don't know how many of you have done any work in C or C++, but I feel like that's the only place I've ever seen any unions actually used. And in C#, you have to go through a lot with struct layouts just to define a union-like object. So need to reintroduce unions to people and also decide whether they're worth using in your GraphQL API. And there's no standard on errors. There are, when requesting data through, say, HTTP, they do suggest having some kind of practice when it comes to error and just being consistent. Are you going to succeed with failure on your queries, or are all of your queries going to fail outright? So do you want partial results, or do you want results that are 100% always successful, or failure? I don't know if, yeah, so that's about time. So we could probably talk more about those at the later portion of this. But yeah, so that's just a good rundown of GraphQL, what it looks like, some pros and cons.
All right, thank you. The final one before we start the panel discussion will be gRPC, and John Regner is here to talk about that.
Sure thing. Hopefully my video holds up. Otherwise, I'm going to throw into the chat a link to my slide deck. And we get screen share up and running.
We can see your screen.
All right, great. So I'm going to be going through the third of our API protocols that we're going to be talking through, gRPC. A little bit of background about myself. I became a dad pretty recently. That's my daughter you see there. She's turning 1 next month. She's plotting out the microservice architecture materials. In terms of my professional experience, I've been working with API development for pretty much my entire software development experience, over a decade of working with, REST, SOAP, WCF. I've experimented with GraphQL a little bit. I don't have anything productionable out of that. And then, of course, gRPC. You can see here some social media links and references in case you want to reach out afterwards. But in terms of what gRPC is, breaking down the acronym, stands for Google Remote Procedure Calls. So like you saw with GraphQL being a protocol that's sourced from Facebook and developing that internally and then open sourcing that as a API system that others can use. gRPC has a similar history to it. Extends a bit further back to a previous framework that Google had started building out internally around 2001, known as Stubby. And so this was their mechanism for enabling inter-service communication. They were building out a massive microservice system, and they wanted their services to be able to talk to each other as efficiently as possible. That framework evolved over time, and around 2015 is when it became open source as gRPC. Two major things that kind of came with that. You can see here are the definition and how it runs. So gRPC is defined through a interface definition language and binary message format known as protocol buffers. And so unlike what you saw with REST and with GraphQL, where it was plain text-based JSON, maybe XML, gRPC is by default working off something that is not human legible. It is shaped into a binary string to be as optimal as possible in transferring over to wire. So that is one major component we're going to dive into with gRPC in terms of how it works. Another major aspect of how gRPC runs is that it is always running with HTTP 2.0. And so that was a major component with it being introduced as a framework and a project for others to consume. It is built off of the 2.0 spec, which among other things includes request multiplexing and being able to natively stream messages instead of having like a pure just like request response exchange. And so we'll see some benefits of that in a little bit. So kind of going a bit deeper into that interface definition language, here you can see the example, and what you saw with some of the GraphQL definition. It's relatively legible if you've experienced any sort of C-based language. Within this, you can see two major types of elements that are being defined. One of them is a message, so you can think of this as like an object or any just like plain component. You can see I've got a point message, and it's got some basic scalar types in it, 32-bit integers, latitude and longitude. You can see I've got a feature message, which has a string, as well as it can inherit through composition other types. So I've got a point location within that message as well. And then at the top, you can see the interface that I'm defining for my service function. So you can think of this as like a contract that you would define for, if you're working within Web API and or have an interface that you're defining for a service that is going to be called. So with this example here, you can see I've got a single function called getFeature. It takes in a point as an input, and it's going to return a feature as an output. One other thing I'll note on this that may kind of jump out as a bit odd at first glance is this numbering that's happening within the message definitions. So one of the big things that comes with protocol buffer definitions and with gRPC is that it is very deliberate about the message structure and setup as a means of optimizing the content that's transferred over the wire. And so that means with your message definitions, you have a sequence of the fields that are going to be specified. Here we've got latitude as field number 1, longitude as field number 2. And so this results in a couple different benefits you can realize from a performance perspective. It means that with each time we're making a request, a response, or sending a message within gRPC, I'm not passing along the name latitude or longitude with each time I'm sending along this message. I'm going to know that field number 1 in point is always latitude. And so either side, server or client, is not going to need to communicate that at any point as they're communicating about this message or with this service. Another thing that this leads to is it also provides a means of being able to version effectively within these messages. So by establishing that sequencing, you can make it clear as you're bringing in non-breaking and breaking changes. You'll, through the numbering, be able to introduce them sequentially later or deprecate fields by removing them from the sequence. The next step from this interface definition is a code generation. So this .proto file that you would write up can then generate code for anything to be able to talk about these messages or these services within really any major tech stack you're going to work in. And so through using the tooling of gRPC and protocol buffer, you can generate class files and stub objects for these messages and services within any language that you work in. So you can kind of see from this diagram, you can think of applying the generation from that protocol buffer file into being able to generate this server and generate C++ code that runs that getFeature service, and then being able to generate these stubs, these service clients for different clients in different languages, different frameworks, to be able to talk about those same messages, those same services, and they'll be able to understand each other explicitly. So you heard about with REST and with GraphQL, these elements of predictability and being able to predict kind of how the messages are going to be handled. With gRPC, it's a different approach. It's less about prediction and more about upfront definition. This is the contract. This is the way we're going to talk about things. And here's the way to generate the logic to be able to make that communication happen and understand everything. And so that leads to a number of the major benefits that you'll see with working with gRPC is that it is very performant. That combination of having that contract up front, having that strict specification, as well as the binary message format means that being able to have communication with these service definitions, these message definitions, is gonna be lightning fast. It's not to say that you're gonna see like a performance issue when working with REST or GraphQL, but gRPC is set up to a scale of being able to work as quickly as you could reasonably work with a major API protocol framework. So that's a major focus and point of emphasis in working with gRPC. With that code generation, you step away a little bit from that predictability element and establish explicitly kind of this is the code that you're going to be able to use to work with this service or to be able to run this service. And so that is provided directly with the gRPC project. If you go out to its GitHub, you'll see all kinds of examples running in any major language off of the same proto files. They're all generating from the same interface definition, but they're all able to talk to each other. And so that in combination with that strict specification makes it very clear to work through type matches and things like that. A lot of that is baked into gRPC to be able to handle that translation between, maybe integers are talked about slightly differently between C++ and C# and Ruby and Python, and it handles all that mapping and consolidation for you. One of the other big benefits you'll see with gRPC is that because it is running off the 2.0 spec for HTTP, it's got streaming support built in. So you can have a server continually streaming messages to a client. You could have a client continually streaming messages back to a server. You could have bidirectional streaming. It's set up with that out of the box so that you don't have to rely purely on a request response type message communication format or polling for new updates or anything like that. It's something you can just configure out of the box with your definition of a service. And then a final major benefit I want to call out, kind of specific to this user group, is that gRPC has been growing in its support and backing from Microsoft. It's had support for C# and the .NET framework for pretty much as long as it's been open source and available to a broader audience. One of the big things that's picked up recently, especially with .NET Core 3.0 and 3.1, is gRPC becoming more of a first-class protocol and element of the .NET Core ecosystem. And so you can set up new, there's project types that you can start up in a solution that will add gRPC support or definition right out of the box. You've got, with that, a lot of documentation and support within .NET in particular from Microsoft's documentation on how to get running with gRPC. It's very clear that this is also kind of like the heir apparent to some of their previous messaging systems like WCF. And so if you're looking to, migrate from that, which doesn't have a lot of, real active support in .NET Core, into a newer messaging service that supports, that strong typing or even like the duplexing that you may have been using in WCF, gRPC is kind of the heir apparent, the next step to go through from there. And so that's a particular thing to consider, is that Microsoft's been aligning it very well with kind of what they're doing with the .NET ecosystem as a whole. Now, that explicit typing and some of the other particulars of gRPC are not without their drawbacks. As you saw from REST and GraphQL, it's much easier to be able to discover things when working with those APIs. With the human readable payloads and messages, as well as the fact that they're running off of HTTP 1.1 or other protocols that are supported natively by browsers. Between those points, it's a lot easier to just kind of poke at endpoints and different resources with REST or GraphQL than you can with gRPC. So if you're looking to kind of get into some initial like experimentation or exploration of a gRPC endpoint or API, it doesn't quite work that way. That leads to a bit of a higher learning curve, especially compared to REST, because you can't just go poking and getting results back. You need to have that definition, that contract that's agreed upon, and then have a client that's generated that can talk to that service. And so that it takes a bit more time to set up and get running with. It also means that compared to REST in particular, you're not going to see as much of a level of community support or prevalence of the usage of gRPC. And so that's another thing to keep in mind. You'll probably see roughly the same amount of support as you see with GraphQL in terms of they come from kind of similar backstories. They're about the same age, being open source in around 2015. But that's another thing to consider. If this is your first time building an API, gRPC is going to be tougher to approach. A particular thing with Microsoft support is that they have been introducing a lot of support in .NET Core for gRPC, but it's not all there. In particular with HTTP 2 support, you're going to run into some odd things that if you aren't thinking about, you may stumble on as you're exploring and getting started with gRPC. One example I call it here is with Azure App Services. So if you're looking to deploy like a .NET service into Azure App Services, you're going to run into challenges with its HTTP 2 support. There are workarounds around that. You can bring in other packages or proxies or things like that. But there are a few hiccups like this that if you take a non-conventional route in terms of like .NET in combination with like Azure or like other elements in the Microsoft ecosystem, you may trip up on something. And there are solutions out there, but it's not always, just unpack out of the box and play around with whatever environment or tech stack structure that you have, in particular with Microsoft setup. So just it's something to be forewarned about. In terms of what are you going to actually use gRPC for, with that emphasis on performance and less the emphasis on the discoverability by the client and more of this is the contract, this is what we've agreed upon in terms of a communication and a spec, you're going to see it being most useful in internal APIs. You have services that you're building that are talking with each other that you want to have perform at scale. You want them to have a clear understanding of what they're talking about in terms of the strictness of the specification and the definition of what they're talking about, and being able to even enforce that across technical stacks. So if you're building a bunch of microservices and you potentially got areas of that built out in C# or with TypeScript based setups or anything like that, this allows you to be able to have them talk to each other in a way that is going to be efficient and is going to be able to perform and be able to be maintained well at scale. Another aspect of performance that you'll see benefits from with gRPC is if you're working with IoT or other low-powered devices. So one benefit from being able to run more performantly than other API protocols is that gRPC makes for a good case for something that you could apply to if you've got services that are communicating with IoT devices or other things that are managed as part of your broader product set. And so that's another consideration in another case like of internal APIs where you have a significant oversight over the definition of the contract and the implementation of the services both on the client and the server side. Now, if you're looking to get started, I've included some links at the tail end of this slide deck. These are focused on kind of the general gRPC GitHub project. Getting started with .NET Core 3.1 if you're looking to jump right in, just fresh, as well as a broader reference for C# if you're not working with the latest .NET Core, or you want to get into exploring kind of how through their quick start and their other documentation, how to get this working with other tech stacks or other languages or anything like that. So with that, that's my prepared content, and we'll jump over to the panel.
All right. Thank you, John. This is where we'll start the panel, but before I do that, I just want to ask, does anyone have any questions at this point? We can start with that, and then if you want, we'll start with some more of the panel questions. Otherwise than that, get your questions ready and we can start the panel discussion. Either use the chat or raise your hand, and then you can speak your question and to whoever you'd like, or all of them. And so that'll be the logistics regarding that. So thanks for attending. We've got and Mark has a question here. Which one of these would you consider the Empire, the Resistance, and the criminal underworld?
Is this where we make all the Google jokes now?
I don't know. Anyway, that's a good one. Anyone want to take a crack at that one? All right. I'll have a question to start this off. So, has there been a specific project, and how has it benefited from your API protocol? What challenges were you overcoming that this protocol helped to solve? I guess I'll start with the order of the presenters. So, oh, I don't have it up. Forgot the order. All right. Come on. Dan.
Yeah, there I can't really call on one particular project that was a great shining example of REST, because all of them have involved REST APIs in some form or another almost. But one thing that I think is really helped me is the fact that it is baked in so fundamentally to just about every web application platform out there. Like, it's hard to find a web framework that won't let you build a REST API kind of automatically. So for that reason, it gets you really. It's the thing that you learn in every getting started tutorial in the world, right? Except for the GraphQL and gRPC getting started tutorials. But the thing you have to pay attention to is that while you have all this enablement of exchanging HTTP messages, it's still a little bit on you to make sure you're doing that with the RESTful principles, right? Like I was a lot less specific in my presentation because REST isn't a specification in the way that GraphQL and gRPC are. It's more of a set of philosophies almost. So that's kind of the back and forth with that one for me.
All right, thank you. And Martin.
Yeah, so a specific use case that I found GraphQL lent itself well towards, or I would say, oh, I'm sorry.
Yeah, how your project has benefited from the use of the protocol.
Yeah, I would say that from the past few projects I've worked on, the biggest benefit is providing a more developer-centric API gateway. As a lot of people go towards microservices or are already at microservices, they really kind of want a way to aggregate those APIs back together in a non-coupled way. And since the design philosophy of GraphQL and the way it resolves the data is meant to be as thin of a layer as possible, that layer being GraphQL, it's easy to describe an API gateway as a developer. Instead of using, say, a hosted or installed service that is more configuration over development.
All right, thank you. And John.
Sure. So one area where gRPC has been helpful in terms of introducing into projects has been cases where you have like an RPC type paradigm or mentality already in mind with a process or a system that you're working with. And so that's been one great way to kind of introduce or get that embedded within like a broader service architecture, is to be able to apply it like you would have with like SOAP or WCF or like Windows COM in the past. And so keeping in mind that there are ways to be able to provide like a REST or REST style interface to like an external audience. Even with working with gRPC internally, that's one good way to kind of approach it, or one type of project where it can have a great benefit.
All right, thanks. I know there's some questions in the chat. Does anyone want to ask any questions that's coming to the top of their mind before we'll go to the new topic? Feel free to talk if you'd like. All right. Okay, so this next question, wait, here we go. We've got, does GraphQL or gRPC have their own mechanism for authentication or authorization, or do they use built-in standards for that? Who'd like to take the first shot?
I can do that for GraphQL. So GraphQL doesn't need to be implemented over any specific application protocol. However, if you are doing it over HTTP and you're using a lot of the common GraphQL frameworks that have been implemented for almost every language that's out there, it's not really going to define it for you. So typically what happens is you'll end up just using what you currently have and having GraphQL as an endpoint that's behind that authorization.
Cool. John.
So for gRPC, from like a general security standpoint, you're going to have like SSL type options. They're included in there. So if you want to do like a client certificate, that's one option that you have for an authentication authorization. It also comes out of the box with OAuth token support. So being able to work off those bearer tokens. And then with .NET Core in particular, that those authentication interceptors are able to work with other authentication mechanisms that the Microsoft stack often works with. So if you're looking to integrate with Azure Active Directory or things like that, you've got additional support and ability to be able to bring that in with your gRPC services.
Great, thank you. Any other ones? Okay. All right, so have there ever, sorry, let me start again. Were there any implementation challenges in adopting your protocol, like was in your experience with your projects you've been working on? We'll go with Dan.
Yeah, the biggest challenge with a RESTful API is, in my opinion, it's the things that GraphQL and gRPC solved first, which is the data schema and being very specific about what formats things are going to be in and what it's going to look like when it gets to you. If you have the same team working on the client side and the server side, and you can communicate well about what that interface is going to look like, you're in good shape. But you also end up implementing it twice almost all of the time. You have to write your TypeScript definition if you're doing that on the front end, and you have to write the C# definition on the server. And I've tried very hard to find a cross compiler or something that will translate my C# classes into TypeScript interfaces, but they're just not there yet. So you have that kind of double typing on both sides you have to deal with. I don't know if GraphQL automatically will generate anything like that on the TypeScript side, but I know gRPC will with its proto files. That's all kind of defined for you. So that's probably the biggest challenge in my opinion, is just being able to communicate that spec back and forth. I see Nick comment, isn't that what Swagger is for? Yes, that's exactly what Swagger is designed for. It's not the ultimate solution for everything, but if you're not familiar with Swagger, what that does is it allows you to define what those objects are going to look like from the server side on your API, so that you can have kind of a spec file that it's machine readable, and it usually gets translated into nice looking documentation and everything too. So that's a really great tool for locking down some of that stuff and still giving you the flexibility that a general HTTP interface does, but being able to define in specific places, this is what my objects are going to look like. It's a little additional work to get that set up, and it's not, it doesn't cover every single use case, but it is a very good tool and helps with a lot of things. So.
All right, thanks. And Martin.
Yeah, the two specific examples I would think about is just having to re-examine opinions on how data is laid out in the API layer, rather than having your data shown as a loosely coupled relationship. You're looking more at it as an hierarchy and the paths that lead to those relationships. So you'll have an object defined, it'll be found in multiple locations within your query. And because there is so much of a focus on not coupling or anything or not duplicating anything, keeping things dry, that's just kind of a hurdle to get past that mindset. For a GraphQL API, you're not looking to not repeat, you're just looking to make the data as easily traversable as possible. And then also understanding the nuances of the tools and frameworks that you're implementing your GraphQL server with is the other challenge. There'll be some things that when you look directly at the code you're implementing, it's going to seem not intuitive. However, because it's taking advantage of things such as memoized result sets, you're going to actually see what people would say is a bad duplicate request that actually won't be a duplicate request, and just kind of working through those implementation details was a big challenge.
All right, thank you. And John? Sure.
Kind of two general ones come to mind. One I kind of touched on already is that the HTTP 2.0 protocol version, just that you may come across hiccups with being able to get started in relation to running with that protocol in particular. So that was something that I came across early on with gRPC. It may be significantly better now, but running into challenges with load balances or other network type setups where it doesn't have the support quite that it claims to with the protocol, because it's about the same age as gRPC itself, 5 years, and so that being something that kind of comes into consideration, given that is that arrives explicitly with usage of gRPC. Another thing to kind of work through in terms of a challenge is kind of testing and debugging of your gRPC endpoints in services, because you don't have that kind of human readable discovery aspect. You need to be kind of more deliberate in your approach to testing and your investment in testing. And so you're not going to be able to hit your gRPC endpoints like postman or something like that if you're building out some initial cases for different types of requests. You're going to be using a client stuff and being able to build out your integration and testing automation through that. And to be effective with the testing requires a bit more of that upfront investment to be effective with it. Kind of another thing related to that testing is because it's in that binary format over the wire, that brings some additional challenges with being able to debug and get logs effectively. And so you're not going to have just like as the request arrives to a service or is sent from a client as something that you can work off of in a human readable format. You're going to need to attack from kind of the points before and after serialization and deserialization, be able to see what you're working with if you're trying to troubleshoot an issue. And so that being another thing to consider in working with gRPC and being able to maintain it effectively.
All right, thanks. We'll have one more question, and then we'll wrap this up. But so this question would be, for your next project with similar requirements, would you use the same API protocol? What would you choose if it's different? And we'll start with Dan.
Sure. So I've used REST APIs and GraphQL in production. gRPC hasn't made it out of the lab for me, but I did really enjoy using GraphQL, and it takes a little more thoughtfulness to create those data schemas and to set up your debugging tools, but and there's a little more consideration because of the level of flexibility that you're giving yourself in terms of kind of like Martin was implying, it's easy to DDoS yourself with a poorly formed request. So you have to put a little more thought into what you will and won't allow, and how those queries are going to play out if it's not tightly aligned to your database. But I think those challenges are rare enough and surmountable enough that's probably what I would turn to for any medium to large size project is GraphQL first. REST is super flexible. It's super easy to get started with. But the more it scales, the more it grows, the more challenges you run into. I want to address Mark's comment here too. He's asking, doesn't Odata allow me to minimize the request like GraphQL? Yes. So if you're not familiar with Odata, it's a standard set of query parameters that you can put at the end of your URL. I had one example in my slide deck, but you can there's filters, there's selects, there's top, there's kind of common query parameters there. And if your API implements an Odata interface, you do have similar control over reducing the number of properties that come back to you, and in some cases adding additional properties. Again, the downside is that it's possible to write a REST API without that. It's the same as Swagger. You don't have to do it with GraphQL gRPC. You must define a schema. You must have selectable properties. Or I guess it's not as selectable on gRPC, but that's kind of the ability and disability of REST is we have these tools like Odata and Swagger, but you have to actually do that. It's not baked in like it is with other options.
Cool, thank you. And Martin.
Yeah, not the easiest question to answer, as I would say it's definitely use case specific. For instance, if I'm going to be serving a bunch of unknown clients through my API and my product is my data, or I'm going to be deploying to multiple different platforms and such as web or mobile, VR, what have you, I would definitely go with GraphQL. However, if I need to get something up and running really fast and I need all the infrastructure support that already exists, I'm most likely going to go with REST. And actually, this kind of leans towards another one of Mark's questions. I'm actually an advocate for GraphQL for your front end and service-to-service communication using gRPC. But if I had to pick one, I guess I'd pick GraphQL. It's a bit more entertaining to use, and I don't like having to, really focus on the philosophy of the design of my API. I just want to build it out.
Cool. Thanks. And John?
So my answer is thematically pretty similar to what Daniel and Martin called out. I have less experience with GraphQL, but I am interested in diving into it more. I've been working off a couple of Odata-based interfaces that have been helpful, but I've been looking for something that's really more purpose-built for being able to request different types of data and different shapes of data. And so definitely have a personal interest that would drive me towards exploring GraphQL more for future projects. But, as they both kind of called out, you have purpose-built cases for gRPC and for GraphQL in terms of external access to data from a variety of clients, being able to have efficiency with internal services and service-to-service communication, and then REST as a great catch-all, especially if you don't really have as good of a grasp on kind of the types of cases you're going to cover with your API technology.
All right, thank you. Does anyone have any other questions in the chat, or they want to ask personally? This is your last chance. Well, you have them here in front of you. Okay. Thanks. As you noticed, there is Lindsay put a message out in the chat. If you want a chance to win a gift card to a local Milwaukee restaurant, she's giving away to one lucky winner. So make sure you send your favorite Star Wars character to her email address. It's in the chat. And so there. And I also want to say thank you to the speakers, Dan, Martin, and John, who have stood up to speak and put up with me after we rescheduled from back in March, I believe, where, with COVID hitting, we didn't know what was going on, and turning this into a virtual event. So thank you very much. As a reminder, we have a few more meetings coming up. So we've got the .NET Docs show where they're going to talk about the Blazor app they have on October 13th, and .NET 5 in November. And thank you, everyone, for attending. Have a great one.